Patience is the mother of science. But in Spanish, it's a rhyme. Patience. Where's my calculator? I used it just last Friday. Yeah. Sorry, it was there. I'm just in my table, not in my back. In my. Please admire my backpack. You know. Remember what I told you about the flowers in the samurai? In Japanese culture, men can wear flowers without being women. Here in Europe, I should when I bought this, the guy in the shop, I don't remember what, never considered the possibility that it was for me. He considered it was for my daughter. Okay, and when I used this bag, so I got like, is he really using this bag? Yeah, but I loved it. Remember when I talked to you about the umbrella I had with the balloons with different colors, and they laughed at me, and I stopped using it, and I regret it ever since. It was maybe when I was 7. Okay, last year I bought this, like at last I can accept that I like colors, flowers. I like pink, this fuchsia. I don't know if you say that in English, fuchsia, very much. So, okay. So what we want to do is to use the least square minimization to get the equation that relates the number of portions with the mass of the piece. So just knowing the weight during the auction, you know, in, I don't know if it happens. I think that it will happen in every country, but here fish are bought in an auction, okay, every day, fresh fish, and it's quite peculiar because the auction doesn't go up, okay. So for instance, 10 euros, 12, 14, 15, no, it goes way down. So the fisherman or the fishmonger, or well, maybe the fisherman sets the maximum price, you know. I think it's not realistic anyway. So if you really want it, you have to offer that price. If nobody offers, it starts decreasing, and then if you want it and you want it cheap, you wait. But if somebody wants it, is able, you know, wants to pay it more expensive, you offer, you raise your hand. It's not open. It's not an open auction. You have to be known by the people. Okay, I've been several times. When I was very young, I went to work in a restaurant, so I went with the owner to buy fish. It was quite early, I remember. Yeah, but anyway, so he wanted some prawns for clients that had booked the restaurant. So he really wanted the prawns, and he was going to get a very good price. So he really needed them. So they started the price, and it's just Barry didn't wait, and the other say, "Come on, why are you doing that?" You know, like, yeah, and the guy say, I can't afford, you know, not going to my restaurant with these prawns. So this chef also goes to told us that they are sometimes, not always, goes to the auction, yeah. So he sees the weight of the piece, and then he quickly gets the calculator, and by the, you know, he makes an estimation of how many rations or portions he's going to sell, and the price. So with this, he quickly knows how many portions can get from the fish, and make these calculations about if he's going to be, if he will have benefits or not. Okay, So from the mass in kilograms of the haddock, you can make a quick calculation about the number of portions that okay, from mass to number of portions. How we get to go to the math and to the least square minimization that Gauss developed. So we can do it with in every calculator. So let's start. Yeah, the linear one. Okay, it's prepared for enter the x and y. The x is the independent variable. The weight of the fish can be anyone. Yeah. So 0.5, 125, you know, depending, it's a random variable. 3.4. But the number of portion is not random, depends on several factors we don't quite understand. Okay, but yeah, it's not random, depends on the weight of the fish, the size, you know. 8 and 9. Okay, so let me here. Okay, enter the data. Let me check them again. 21.55, 28, 3.49. Okay, so I think we are ready. So the equation that relates R and the number of portion is 1.737 plus 2.385 mass in kilograms, okay, with a correlation coefficient of, not bad, the correlation coefficient is 0.93. So this 93 means that the variables are correlated in a 93.3%. Okay, so there's high correlation between the mass and the number of portions. So when the mass of portion increases, then the mass of the fish increases, the number of portion increases in the same way, in the same proportion. That's why we can get this equation. So let me make a small calculation. Just a quick test, and I'll tell you later why I'm doing. A plus 7b 1.85. Yes. So what I did is I substitute a numerical value of 1.25. Okay, 1.25, which is this will be this point. So yeah, the real value, okay, the empirical value is 5. See the table, but the equation gives 4.7, you know, which is slightly, yeah, this point is slightly below. Okay, yeah, so it doesn't quite match all the points, but it gives the best choice, right? The best choice so they are equally close or equally far to all the points. So why this